Today is January 16th, and this is the hard daily integral for today, so let's start. So notice that we have the floor function here. So we're going to have to split this integral into intervals. So let's say we go from n to n plus 1. Okay, so if we start at, let's say, we go from 1 to 2, right, not including it, then on this interval, 4 of x is equal to 1, and floor of x plus 1 is equal to 2. Then if we go from 2 to 3, but not including 3, then we have floor of x is equal to 2. So what we're going to do is split this integral onto intervals like this, from n to n plus 1. So this will now become, so we take the sum from n equals 1 to infinity, the integral from n to n plus 1 of n times n plus 1 over x to the fourth, since x to the fourth has to remain the same now. So we have this integral. Now what we can do is we can take out the n times n plus 1, and now we have the integral from n to n plus 1 of 1 over x to the fourth dx. This now we can integrate. So we have n from n equals 1 to infinity, n times n plus 1. This integral this becomes negative 1 over 3 x to the negative third from n to n plus 1. So now we can take out the negative 1/3, and we'll have the sum from n equals 1 to infinity, n times n plus 1 over n plus 1 cubed minus n times n plus 1 over n cubed. Now we just need to find the sum of this infinite series. Okay, so we have the sum from n equals 1 to infinity. One of these cancels. One of these also cancels. We have n over n plus 1 squared minus n plus 1 over n squared. Okay, so notice that we have n plus 1 squared and n squared. What our goal now is to make this into a telescoping series. So how can we make this into a telescoping series? This is n plus 1, so we want this to be the previous term. So we want this to be n minus 1. So let's see how we can make this n minus 1. Well, we have the sum from n plus 1 squared. We want to make this minus n minus 1. So this is really a plus 1, right? This was so here we made this was a minus 1 here. Now it's a plus 1. So we added 2 here. So we need to subtract 2 over n squared. And now we have this infinite series. Now let's split this apart into two parts. One is our telescoping parts, n over n plus 1 squared minus n minus 1 over n squared minus, so we have this other infinite series, and we'll take out the 2 of 1 over n squared. So let's first look at this telescoping series. When n equals 1, we'll have 1 over 2 squared minus 0 over 1 squared. Then we'll have plus, we'll let n equal 2, we have 2 over 3 squared minus 1 over 2 squared, and this will go on and on. So we'll have this term cancel out, this term will cancel out later, infinitely all those terms will cancel. So we'll be left with minus 0 over 1 squared. This is just 0. Then let's look at this part. Well, so this right here is just the basal problem, right? This is the zeta function at 2. So this is equal to pi squared over 6. So we have negative 1 over 3. We had 0. We have negative pi squared over 3. So we get pi squared over 9.